Howdy. Obviously, a year ago or something, I made a video which has the name Continuous Ash Plumes are like antennas for more energy. And there's obviously also a video with the name of Volcanic Electrification. I will put links below. I won't show now you those videos, but I think the principle is the same. Since there is energy going up and energy goes always both ways, there is energy also coming down. And that's something that's a rather simple, what is it? Not a phenomena, but it's a rather simple thing to somehow imagine how the world, everything, the universe works. Energy almost never just goes one way. It doesn't mean that they meet at the center or at the middle point, but there is always an energy exchange going on in both directions. And yesterday, I think I found an interesting article. And maybe found is the wrong word because I wasn't searching for this kind of stuff. I was just looking around and see what's coming. What's there? Is there anything interesting? I thought that's interesting. New study shows Tonga's Tonga eruption produced the most intense lightning ever recorded. Yeah, you can take your time and check out the pics. The January 15th, 2022 eruption of the Tonga volcano in Tonga continues to break records. So whatever stuff they measure about that, it breaks records. According to a new study, the eruption created a supercharged thunderstorm that produced the most intense lightning ever recorded. Yeah, they don't record lightning since a very long time compared to how long it has been going on. So their knowledge about it might be rather limited, especially when thinking about electrogeology and stuff like that. My microwave experiments and stuff like this, like how much you can achieve if you put enough energy in the circuitry. There were nearly 200,000 lightning flashes in the volcanic plume throughout the eruption, peaking at more than 2,600 flashes every minute, the researchers found. When the submarine volcano erupted in the southern Pacific Ocean, it generated a plume of ash, water, and magmatic gas at least 58 kilometers high. At least. The towering plume gave scientists useful information about the scale of the eruption, but it also obscured the vent from satellite view, making it more difficult to track changes in the eruption as it progressed. There is high-resolution lightning data from 4 separate sources, never previously used altogether, have now let scientists peer into that plume, teasing out new phases of the eruption's life cycle and gaining insights into the weird weather it created. We are reading fist.org, and I assume that most of the people involved in writing onto this web page or contributing stuff which they then publish, and they are professionals about whatever or in whatever branch of science they're working in. And they're talking about weird weather. If something is weird, it might indicate that you probably don't really understand the thing. But anyway, this is just what I think. This eruption triggered a supercharged thunderstorm, the likes of which we've never seen, said Alexa Van Eaton, a volcanologist in the United States Geological Survey who led the study. Yeah, now I just realized one thing. That's almost hilarious. This eruption triggered a supercharged thunderstorm, the likes of which we've never seen, said Alexa van Eaton, a volcanologist at the United States Geological Survey, who led the study. Let me show you one thing. So now let's do it like that. We go over to the NCGT journal, go to journals, and here the first one, volume 11, number 1, March 2023. It's a download, and I don't know how many times I've downloaded this already because I probably should rename it once in order to find it quickly. But until this day, we go like that. While mountain water, a new approach to mountain forming volcanism, glaciers, and the role of water in an electric environment. Then we scroll down and down and down. I recommend you to read the whole journal. There is a lot to read. And very, very interesting things are here. It doesn't matter where you stop scrolling, you will find something very interesting. Expanding Earth, for example. But we want to go to my mountain water paper. And hopefully we'll... No, it's not still. It's maybe the next one. Mountain water. Mountain water. Abstract. People settle near water. Almost all life forms need water. Water is very important for life on Earth. Consensus theory explains the circle of water through evaporation, precipitation, accumulation. Meteorologists don't know much about volcanoes. Volcanologists don't know much about weather. So now we have been reading here the Tonga. This eruption triggered a supercharged thunderstorm, the likes of which we've never seen, said Alexa van Eaton, a volcanologist at the United States Geological Survey. She's talking about the weather. Meteorologists don't know much about volcanoes. Volcanologists don't know much about weather. You know, I wrote this here in the paper many months ago. This is somehow hilarious. I didn't notice this early when I read the article. I don't even know if I read the whole article, like until the really end, but yeah, let's just read still 2 sentences or something. This is how modern science works. Specialists for every small diversification of whatever science branch. How could anyone within that paradigm ever get a holistic picture of the whole? It is full of contradictions, misinterpreted results, and it also seems to keep certain mysteries alive. But now let's go to the article. I just found this somehow like interesting, that we have a volcanologist who's talking about the weather. But anyway, these findings demonstrate a new tool. We have to monitor volcanoes at the speed of light and help the USGS role to inform ash hazard advisories to aircraft. We have to monitor volcanoes at the speed of light. Yeah, maybe I should send her my volcanic plasma phenomena. I will put a link below. That's a playlist about volcanic plasma phenomena. Different kinds from different volcanoes. Very interesting. But let's go back to the article once again, and then we stay there. I don't want to interrupt anymore. We just make a read through, and that's it. Yeah, like, who are we? I am talking in the third person of myself. No, not really, but it's sharing. So, but anyway. The study was published in the Geophysical Research Letters, which publishes high-impact, short-format reports with immediate implications spanning all Earth and space sciences. All right. The storm developed because the highly energetic expulsion of magma happened to blast through the shallow ocean, Van Eaton said. Molten rock vaporized the seawater, which rose up into the plume and eventually formed electrifying collisions between volcanic ash, supercooled water, and hailstones. The perfect storm for lightning. Yeah, because they think the ice crystals rub together and they create the lightning. I doubt that this happens in a volcanic ash plume. Combining, otherwise we would have snowfall after every volcanic eruption, maybe. But I don't know. I just don't think so. It happens like that. Combining data from sensors that measure light and radio waves, the scientists tracked lightning flashes and estimated their heights. The eruption produced just over 92,000 flashes, made up of nearly 500,000 electrical pulses, peaking at 2,615 flashes per minute. Some of this lightning reached unprecedented altitudes in Earth's atmosphere between 20 to 30 kilometers, 12 to 19 miles high. There's a video, which is probably made much better than mine. With this eruption, we discovered that volcanic ash plumes can create the conditions for lightning far beyond the realm of meteorological thunderstorms we've previously observed. Van Eaton said, "It turns out volcanic eruptions can create more extreme lightning than any other kind of storm on Earth." The lightning provided insight into not only the duration of the eruption, but also its behavior over time. The eruption lasted much longer than the hour or two initially observed, Van Eaton said. The January 15th activity created volcanic plumes for at least 11 hours. It was really only from looking at the lightning data that we were able to pull that out. The researchers saw 4 distinct phases of eruptive activity defined by plume heights and lightning rates as they waxed and waned. The insights gained from linking lightning intensity to eruptive activity can provide better monitoring and nowcasting of aviation-related hazards during a large volcanic eruption, including ash cloud development and movement, Van Eaton said. It's a significant challenge to get reliable information about volcanic plumes at the beginning of an eruption, especially for remote submarine volcanoes. Harnessing all the long-range observations available, including lightning, improves early detection to keep aircraft and people out of harm's way. Yeah, look at the weather maps, satellite maps. If you can see some really strong weather system somewhere piling up in the middle of the ocean, there might be something going on beneath the surface of the ocean. But anyway, I'm not a scientist. It wasn't just the lightning intensity that drew us in, Van Eaton said. She and her colleagues were also puzzled by the concentric rings of lightning centered on the volcano that expanded and contracted over time. Yeah, energy pulses. The scale of these lightning rings blew our minds. We've never seen anything like that before. There's nothing comparable in meteorological storms. Single lightning rings have been observed, but not multiple. And they're tiny by comparison. Yeah. There's these double layers in the atmosphere, and once it reaches a certain double layer, it just will discharge. Intense high-altitude turbulence was again responsible. The plume injected so much mass into the upper atmosphere that it sent out ripples in the volcanic cloud, like dropping pebbles in a pond. The lightning appeared to surf these waves and moved outward as 250 kilometers wide rings. As if all that weren't enough to make this eruption fascinating, it represents a style of volcanism known as phreatoplinian, which occurs when a large volume of magma erupts through water. Yeah, water. Previously, this eruption style was only known from the geological record and had never been observed with modern instrumentation. The Tonga eruption changed all that. It was like unearthing a dinosaur and seeing it walk around on four legs. Van Eaton said. Sort of takes your breath away. Yeah, Van Eaton, if you think about, or if you would know that dinosaurs, if you would be able to create one of them, comes out of the egg and starts to grow. They couldn't roam the earth because the gravity would be too strong. They would collapse under their own weight. This, in other terms, probably means back then when we had dinosaurs, Earth was much smaller. In other words, it had less, or the gravity force was less, because gravity is tied to charge. Well, anyway, this was the whole article. Yeah, and probably this knowledge could also take our breath away. Yeah, let's check out the video and then I will leave you alone. Do we have any sound to that? No. Yeah, that was interesting. Oh, there's no way to zoom in or something. But anyway, could take a screen record and you could zoom in and stop and pause and all these kind of things. There are these flickering. These rather big areas where we have color. Because here we just have the dots. Do you see it? There was one here. And it would be very interesting to know what they were. But anyway, a rather long video. And yeah, volcanic plumes as an electricity. Very interesting. Thanks.